So hello there, today I'm going to show you how to fix your LED bulb or lamp as you may call it. This one here, it's not working. I've soldered the mains directly from here. This is 230 volts, but the bulb is not working. So today I'm going to show you how to fix your LED lamp. So today I actually have two lamps. Let me first disconnect the power. I have two lamps that are not working, and that's what I'm trying to fix today. Let me just desolder this. This is the first one and this is the second one. I've taken apart this lamp. It's just like this one, just a different brand. This too is not working, so what I'll do is that I'll use my multimeter here to go over the process of checking this LED lamp. So first let me solder the mains back here. So just one more thing, this whole video was shot on this smartphone over here. It's the brand new Techno Camon X. So I would appreciate it if you would check my unboxing video I did on this smartphone. It has quite some nice features: 4GB RAM, 64GB storage, that camera over there, that's 24 megapixels, and this one over here is 16 megapixels. It also has fingerprint sensor as well as Face ID, whereby I can unlock this smartphone just by using my face. So check out my unboxing video as you check this other tutorial out. Before I plug it in the power, first of all, what you do after taking it apart, to take it apart, you just fix your screwdriver inside here and you plug it out like that. You do the same for this too. I don't know why this one is still not working, but today I'm going to show you how to fix this one. So this is how the electricity flows. You have your AC here, and through this capacitor the AC is stepped down to a lower voltage. I don't know if step down is the correct term to use, but it reduces the voltage. Reduces a better term, reduces the voltage. Then it gets rectified by these diodes. This is a full bridge rectifier. Then after that, the voltage is supplied to the LEDs. It's a DC voltage. The capacitor here helps smooth everything, but from here I can see that this capacitor is somehow swollen. I think this may be the problem, or maybe one diode has a short. I'll do this in part 2 of my video, but today I'm going to use this one. Shows how the electricity flows much better. This is my AC line, 240 volts. The voltage gets reduced by this capacitor, it gets rectified by these diodes, gets smoothened by this capacitor, and then is fed by these lines to the LEDs here. So the first thing you check is there is any loose or open connection. From what I can see, everything is soldered correctly, no open circuits. So we are going to test the voltage from the mains up to the output over here. So using my multimeter, I set my multimeter to test voltage from my AC. So first I test the AC voltage over here. The AC voltage is okay. Let me test it over here again. This is the AC line too. the AC voltage is okay at the same place. So after this, let me just test the output voltage over here. First I change it to DC because this is DC voltage. DC voltage is okay too. So the DC voltage over here is okay. So I'm assuming the LEDs, any one of these or a couple of them have a problem. So to test this, I'm going to lay it down here. You see, this one has an aluminum cover to dissipate the heat better. The other one over here didn't have any. Maybe that's the problem. But these are much better quality. This aluminum dissipates the heat from these LEDs much faster. So to test the LEDs, we use the diode test over here. This is the diode test. With the diode test, I'll start from the positive side over here. So what I'm seeing over here, all these LEDs are connected in series. So if any has a problem, all have a problem. In fact, let me use a pen to show you how the electricity flows. This is the positive over here. Electricity flows like this, like this. This is the positive, so electricity flows all the way in series back to the negative terminal. So to test the LEDs, you use the diode test on your multimeter. If I bias it correctly, the LED will light up. So to test the LEDs, I'm going to use the diode tests over here. This is the positive terminal or the probe from my multimeter. This is the negative terminal or probe from my multimeter. On the LEDs, since we are flowing from the positive side, this is the anode and this is the cathode. So I use my positive or red probe and place it on the anode and the negative terminal on the cathode. If I do that, the light will go on. If I bias it in the opposite direction, it won't go on. You can see the multimeter doesn't change. But if I reverse and bias it correctly, it works. I think you can see a little green light. Let me turn off this other light off. Yeah, so that's okay. Okay. As you can see, this one has a problem. Let me continue with my tests, see if there's any other one with a problem. Let me just mark it first. So this here has a problem. Now to fix it, there are two ways I can do it. I can go and buy another LED and replace it, or I can use a shortcut and remove this and just short a cable from here to here. It will work. So you know what else uses this type of lights? Your LED TV. Let me show you right now. So this is a sample of LED lights from your TV. These lights are connected in the same way with this lamp in series, where if one does not work, your TV will not have any backlight. You won't see any pictures from your TV. We will also test these ones using the same method. Place this one on the positive and this one on the negative, and it will light. You can see a little light. In this case, this light has a problem. So this small light prevented the whole TV from working. That's good. That's good. Let's go to the TV one quick moment. On your TV, we have 3 such lights. One over here, another one over here, and a third one over here. If any of the lights do not work, your TV won't work. The only thing you'll hear is sound. Sound will be okay, but the pictures will be somehow faded. So they connected them in series too, because if one light does not work, it's better to have the whole TV not work instead of having a dark spot over here or maybe over here. So let's go back to the lamp and finish our setup. So to finish with our repair, I'm going to need a small piece of wire. I'm going to solder this small wire directly here, and in this way I'll bypass the voltage over here, and all the other lamps will continue working with this one blown out. So after putting in my loop wire, which seems a little long, I'll plug the lamp back into the power supply and see if it works. So let me just shut off this other light and then plug in my other light, this one here. See, it works. It's a green light. I don't know why there is see, that's cool. I think this is the reflection from the camera, but it works. Let me try and switch on the other light. What do you call this? But it works. So let me put everything back together and test it finally. So this lamp had like an insulator. Actually, that's hot. It was on for a few seconds and that is actually hot. So this lamp had an insulator to prevent the open circuit over here from shorting out with the aluminium side. So just replace that, plug in my lamp. And then, but before I do that, let me test the voltage. You remember we had a lot of voltage over here, which I didn't expect. Let me try it one more time and see what voltage normally is across over here. Because if there is an open circuit, the voltage usually goes higher, and when the circuit is closed, as you know, while the lights are working, the voltage usually drops. So check over here. So using the DC test, let me test this voltage over here. Yeah, you can see it's much lower. It's 51 volts. If I reverse it, I'll get minus 51. Yeah, it's 51 volts. So if there is an open circuit, it was 350 volts. When the circuit is closed, as in why the lamp is working, it's 50 volts.